Hello, everybody. All right, so welcome to the second lecture for forces. We're going to talk about types of forces. So today's main goal, and free body diagrams, FBD. Today's main goal is to kind of understand the most common forces that we're going to be interacting with for this unit. And then this FBD, or as I'll say later, is a free body diagram, is understanding the pictorial method of describing all the forces acting on objects. So this would be something that you're going to be doing quite a bit, this FBD business. So today I'm going to kind of lay the foundation for it on the homework that I'll be posting on Wednesday, the 2nd of December. Okay, you'll be doing some questions with that, and I'll explain that a bit more. Okay, so let's start this first part, types of forces. So we'll go most common forces. Okay, so these are the forces that we're going to be mostly always integrating into our situations and our setups. Okay. So the first one is weight. Okay. So weight is going to be defined as the force of gravity acting on an object due to its mass. Okay, force of gravity acting on an object due to its mass, and then it always points vertically downward. Okay, always points vertically downward. Okay, this parentheses W is just the abbreviation we'll give for weight. So weight is the force of gravity acting on an object due to its mass, always points vertically downward. Now, this will be the one I'm going to take a couple seconds extra on. This weight is always acting on you no matter what, whenever gravity is involved. If you are on a planet, you have gravity, you have a weight. Weight does not equal mass. Mass and weight are two completely different things. Okay, mass is how much matter you have and how much space you take up. Okay, weight is a force. So this will be one of the things I get pretty touchy about just in this unit because it is such a different thing. So I will be driving that home as much as I can. Something against you, just every year, okay, you have to kind of fully understand that weight. If you say something has weight, and if you say something has mass, those in this class mean two completely different things. Yes, in your everyday life, you're going to say, what's your weight? How much do you weigh? Okay, and that's just, stuff on a scale and you're good to go. In physics, those do mean two different things. Okay? If we remember, okay, Newton's second law, force equals ma. Okay? Weight has its own equation. You kind of see it in this definition. It's the force of gravity in an object's mass. Okay, when you think about it, you have mass, and gravity we know as an acceleration. Okay, so we could take this in the equation, I'll write that in blue, the equation for weight is going as follows. W equals mg. Okay, Where G, remember that's gravity, that's a positive 9.8. Okay, but also, if you take these two numbers and multiply together, mass, always positive. Okay, I know that I didn't say that earlier, but mass is always positive. You can never have a negative mass. You just can't have anti-mass. Gravity, also positive. So when you multiply these two things together, you will get a positive response. But force, which is my capital W now, is a vector. So weight will be a negative. I'll kind of show that a bit more in a second with our free body diagram. So weight, this is the most common type of force that you will deal with because you're always going to have it as long as you are on a planet. The second most common type of force is something called the normal force. Which is abbreviated to F with a subscript capital N. So normal force is the force between two solids. Never mind, I don't like that definition. How about this? Okay. Force acting on an object perpendicular to the surface it occupies. I like that one a little better. Okay. Force acting on an object perpendicular to the surface it occupies. Please, please, please remember this whole perpendicular to the surface. Okay, that's really, really important. Okay, perpendicular, remember that creates the 90 degrees. Okay, 90 degrees to the surface. Hence the word normal. That's our mathy word for saying perpendicular, 90 degrees, and all that kind of stuff. Another very common type of force is what we call tension. So tension is the force exerted upon via a string, rope, cable, or chain. So basically, anytime you're pulling an object via a rope, a cable, or a chain, we call that a tension force. Okay? So weight, that's the force caused that is always acting due to gravity. Normal force is the force that acts upon an object perpendicular to the surface. Tension force, still force, is any force exerted by a rope, string, cable, or chain. Now, all three of these are types of forces. So all three of these can replace this capital F in Newton's second law. Okay, so please, please, please keep that in mind. Okay. The last two most common types of forces are friction forces. Now there's actually two types of friction forces. The first one is your kinetic friction. Okay? So kinetic friction is the amount of resisting force between two objects that are moving relative to each other. Okay? So, the amount of resisting force between two objects that are moving relative to one another. And then the second one is called your static friction force. You call it kinetic friction force if you want to. Just gotta put the force at the back end of it. So static friction is the frictional force between two stationary objects and the surface, or sorry, between a stationary object and the surface it's resting upon. My bad. So the frictional force between a stationary object and the surface it is rested upon. Okay? So, kinetic friction basically, as objects are sliding across the surface, they have kinetic friction. So that'd be like as a ball is rolling across a field of, like if you kick a ball, it's rolling along some grass. Eventually that ball is going to stop. We just kind of know that's going to happen from everyday life. Well, that's what's causing it to stop is this kinetic friction, for the frictional force between the ground and the ball. Static friction, this would be like if you ever had like those rubber phone cases and you try to slide your phone across the surface, like your phone's like currently at rest. It's like this pen, it's currently at rest. I try to push it, okay, across the surface and I feel some like resistance prior to it moving. That would be your static frictional force. Okay. Now, friction has its own equation. It looks like this. So fancy F is your friction force. So it could be fancy FK, fancy FS. Fn is your normal force. And this weird looking Greek symbol looks like an M. It's not. It's called a mu. Okay. Mu is your coefficient of friction. Basically, mu represents the amount of kind of resistivity that a surface has. Okay, so like ice has a very, very small resistivity, so its mu value is very low. When I say very low, it's like it's a decimal, 0.1 maybe. Okay, whereas if you think of concrete, it's not polished, it's normal concrete that you drive on, is very rough. So that has a very high coefficient of friction. Okay, this equation works for both kinetic friction and static friction. Okay, one little thing is the coefficient of static friction is always bigger than the coefficient of kinetic friction. So mu of S for coefficient of static is greater than the coefficient of kinetic. So basically what that's saying is it's harder to get objects to begin to move, but once they're moving, the amount of frictional force against them is much smaller. Okay? And my 15 minutes is up, so I actually will not be talking about free body diagrams today. This just took a little while longer than I thought it would. So I'll hit free body diagrams up later. You all have a good rest of your time.